Hello, this is the weekly report of the design and the fabrication of microsystem class. We are Team 4, and I'd like to give what we've done during the last week. So this week, we start to do the fabrication process, including wafer cleaning and oxidation. And we implement the simple Whiston bridge and try to get the signal using Arduino. Before fabrication, the first step is the wafer cleaning process. This video is showing our cleaning process in detail. So first, place the silicon wafer into the beaker. Add the sulfuric acid and the hydrogen peroxide to the beaker. Wait 15 minutes. Pour the solution into the designated beaker and take care to prevent the vapor from falling. Rinse with DI water. Next, we'd like to ultrasonic cleaning for 50 to 20 seconds. After taking out the vapor, clean it with DI water again. And repeat for 5 times. Use a air gun to dry the vapor and then save it. Finally, pour the used piranha solution into the waste bucket. So after vapor cleaning, we use the furnace equipment to do the oxidation process. The equipment consists of fluorometer, furnace chamber, and the console. The fluorometer is used to control the flow rate of nitrogen and oxygen in the chamber, and the console is used to set the program to adjust the temperature in the chamber. Based on the equipment video manual, we completed the vapor oxidation step using parameters of 1000 degrees Celsius for 50 minutes to obtain the oxidized layer approximately 300 nanometer thickness. So next, we want to implement a simple Wheatstone bridge instead of our Lear's strain sensor. So we use 3 known resistors and 1 potentiometer to implement the Wheatstone bridge. So when we make our pressure sensor, with the piezoelectric effect, the resistance will be changed and then it leads to change the voltage. And reversely, in order to measure the pressure sensor, we could measure the voltage change and calculate the resistance and get the applied pressure. So this time we only have one potentiometer, but later we will implement it further to use it as a full piston bridge. So hardware is looks like this way. We give 5 voltage into the input port and we implement the piston bridge circuit. Then we connect into the Arduino analog pin input. So under we simple mathematical relation, we can program the code and try to get the measured output voltage differences and then estimate the unknown resistance R4. So this is the result. When we change the resistance manually, we could see the measured output voltage and estimate the R4 in real time, as you can see here. And we try to plot the graph. The blue line means the output voltage, and the orange color line means the estimated resistance R4. So theoretically, when we bring out this become 0, R4 should be same as R3, which is 10 kilo ohm, but it has some error at this moment, and that means proper calibration method must be considered, and there is a big noise, so we will use the filter to and try to improve the sensor quality. In the future, we from the next week we will continue the fabrication process. We have already made the mask, so we can continue the fabrication process, and we also will improve the quality of signal processing part in the same time. So this is all our presentation. Thank you for listening.